Kalispera, Seolus. This is the two words I know in Greek, sorry. I will do my presentation in English. Hope everyone can follow it rightly. So how many of us here today, which are related to the deployment of EV charging infrastructure, in one way or another, have ever faced a situation in which we need to manage sites with not enough power availability? And how many of us have wondered whether the charger could stop being the last link in the chain and become the true center of the charging ecosystem? So my name is Nico Lecea. I'm the sales manager for Southern Europe at XCharge, and today I'm going to share with you how bidirectional charging and energy storage are transforming the reliability and the overall value of EV charging infrastructures. When we think about electric mobility, most of us still picture something very simple, a car plugged into a charger. But we are witnessing something much deeper, a true shift in paradigm. Before shows a linear world, a rigid, centralized energy model where the point of supply was simply the end of the chain. Maybe I use this one? Better? Okay, or yeah, okay. Okay, so now it's better? Perfect, perfect. Now it's a cleaner, more efficient electric world, but still a dependent one. The chargers works, of course, but it remains just a consumer of the grid. Everything flows in one just direction. And next is, however, a living ecosystem. It's the moment where the charger stops being a cost or a bottleneck and becomes an energy asset, capable of storing, delivering, balancing, and interacting with renewables, with buildings, with the grid, and with vehicles. It doesn't just charge cars, it adds value, creates flexibility, and increases the overall stability of the entire system. We are reaching a turning point driven by three forces that reinforce one another. The first one is the explosive growth of electric vehicles. This is not incremental growth, it's a leap toward 215 electric vehicles on the roads by 2030. It's a transformation at a continental scale, it's a huge transformation. Only here in Greece, according to the National Energy and Climate Plan, by 2030, 30% of the vehicles will be electric. The second force is the pressure on the energy system. Costs are rising sharply, and the grid is starting to show its limits. In just 1 year, peak hour prices have increased by 49%. This is a very clear signal that the current model cannot support the demand that is coming. And the third force, of course, is the European regulation, which is not longer a guideline, but a mandate. Europe requires 55% reduction in CO2 emissions by 2030, which forces us to rethink how we produce, how we distribute, and how we consume energy. If we look at the EV charging industry in Europe, the challenges are very, very clear, and they repeat across every country. But what really matters is not just understanding these challenges, but how can we solve them. Challenge number one, limited grid capacity. Solution, using energy battery integration. Result, high power charging with low input from the grid. The second challenge, costly and slow grid extensions. Solution, AC input lower than 50 kilowatts. The result, fast deployment of charging infrastructures. And the third challenge, energy costs. How to solve it? Peak saving with smart energy management systems. And the result, the controlled operational expenses. So chargers are no longer endpoints, but enablers, and can act as active participants in the energy ecosystem. They are now in the middle of the ecosystem. But how is this possible? When we think about what comes next, the element that truly changed the game is the energy storage. The integrated battery becomes the backbone of resilient charging. We are no longer fully dependent on the grid. We can store energy when it's available, when it's cheaper, or when the grid is less stressed, and deliver it exactly when it's needed. The grid provides whatever it can, the battery absorbs, stabilizes, and secures the supply, And the charger always delivers the required power to the vehicle, even during peaks, constraints, or grid instability. When energy storage becomes part of the station, EV charging is no longer at the mercy of volatile grid conditions. It becomes more reliable, more stable, and far more controllable. In other words, with the storage, charging infrastructure stops reacting to the grid and starts anticipating it. And if storage allows chargers to anticipate the grid, the next step is giving them the ability to generate part of their own energy. And that is where photovoltaic integration comes in. Solar becomes an additional layer of resilience. The station no longer relies on a single source. It can draw from the grid, from the battery, and from local solar generation. By diversifying energy inputs, the entire ecosystem becomes more stable, more predictable, and more cost efficient. This is how resilience truly begins, not by depending on a stronger grid, but by depending on multiple energy sources working together. And once you have a storage and local solar working together, something much bigger becomes possible. You can connect these elements, the grid, the battery, the charger, the PV, and even the building, into a single intelligent ecosystem. This is what we call a microgrid. Microgrid brings robustness to a completely new scale. It doesn't just support the charger, it keeps the entire site running even when the main grid is unstable or constrained, and thanks to the battery to grid, chargers stop being passive consumers and become active energy assets. Assets that can support the grid, support the building, and support the CPO's operations. With a microgrid, the site is no longer waiting for power. It manages power, it optimizes power, and it protects its own operations. The future of EV infrastructure is resilient, interconnected, and bidirectional. By turning chargers into active energy hubs, we ensure not only faster infrastructure deployment, but also the confidence customers need for mass adoption. This confidence is not built by one company, one product, or one project. It's built together by CPOs, by technology providers, by grid operators, by policymakers. Let's turn charging stations into resilient energy hubs and together bridge the gap to mass EV adoption. The next chapter of EV charging is what we call GridLink. GridLink is our latest innovation in energy storage solutions for electric vehicle charging, designed to become the center of the ecosystem. The evolution of our original battery integrated system with already more than 250 sites up and running all around US and Europe. It's a powerful system, taking just 44 kilowatts from the grid, capable to provide up to 194 kilowatts of output power, with an in-house developed battery modules with 215 kilowatt hours battery storage capacity, with onboard fire suppression compliant with the higher safety regulations. With the off-grid functions and bidirectional power, the advanced system ensures uninterrupted charging and power supply during blackouts. It can also be connected to photovoltaic systems, supporting direct integration, enabling up to 30 kilowatts of DC direct PV input. And if you want, you can just connect to a standard industrial socket, dramatically reducing the installation time. GridLink is our newest battery integrated solutions, makes DC charging accessible for anyone and anywhere. As our industry continues to evolve, one thing is clear. We have the responsibility and the opportunity to build charging infrastructures that are reliable, scalable, and truly prepared for what comes next. And we at XCharge are ready for it. We make DC charging accessible at any location. Thank you very much.